Welcome you all to session 5 of the chapter Motion in a Plane. We were discussing about projectile motion. An object thrown in air is called as a projectile, which moves under the action of gravity alone. The path travelled by projectile is called as a trajectory. In the last session, we have derived what is the equation of trajectory of the projectile, and the equation came to be y equal to tan theta x minus half g x square divided by u square cos square theta. So this was the equation that we have derived. So this is the equation of trajectory of a projectile, which was similar to this equation, that is y equal to ax plus bx square, right? So this equation is nothing but equation of parabola. That is why we say that whenever an object is thrown in air, it follows the path of the parabola. So we can conclude that the trajectory of a projectile is a parabola, right? If this is a projectile, it follows the path like this, and this shape is called as parabolic shape, and the equation of parabola is y equal to ax plus bx square. So this was the result of last session. Now let us see much more things about this projectile motion. Right. First of all, let us understand what happens to the velocity and what happens to the acceleration during the projectile motion. Let me consider one example here. Right. For example, let me take two axes here. Right. So let me consider this is the x-axis and let me consider this is y-axis. I am taking two axes because we are discussing about motion in a plane. Projectile motion is an example for motion in a plane, which is 2 dimensions. That is why I will be taking 2 dimensions. One is x-axis and another one is y-axis. I will be throwing an object from the point of reference like this. Okay, in this direction I will be throwing an object here, right? So if the object is thrown in this direction, it travels a path called parabolic path here, right? So the velocity which I am giving to the projectile, so that velocity, let me call it as initial velocity, that is u here, right? The angle made by this with the horizontal, the angle made by the direction of the projectile with the horizontal, that is called as angle of projection. So that angle, let me take it as theta, right? So this is always, when the body is moving like this, the velocity is always tangential. That is why I am taking like this. This is initial velocity, right? Okay, I will be resolving this vector now here, right? We will be splitting this vector along x-axis and y-axis because it is motion in 2 dimensions. Okay, if I split this, okay, let me use a different color so that you can understand how we can actually split the velocity. We split this velocity into 2 now here, right? One is along x-axis. Let me call it as u. What we say here, cos theta, right? For this is adjacent side. Let me call it as u cos theta now here, right? So this is a vector, that is what now here, u sin theta. These are called as rectangular components that we have already derived it, right? So u cos theta, and along y-axis, let me call it as u sin theta. Okay, the component along the x-axis, let me call it as horizontal component, right? From now on I will be speaking like this. This is horizontal component and this is vertical component, right? This vector is split into 2 vectors now here. One is horizontal component and another one is vertical component. Horizontal component, let me write it as u cos theta, and vertical component, let me call it as u sin theta. Now, okay, I will be discussing different velocities at different positions of this parabolic motion here, right? Before that, one thing what you need to understand is, when an object is moving like this in a parabolic motion, it moves under the action of gravity alone. Means only the gravity is acting on it. There is no external force which is acting on the object. Means we can say this, the acceleration along the x-axis is 0. Do you understand? Whenever the object moves in a parabolic motion here, right? So whenever there is a projectile, when it is moving here, and the acceleration along x-axis is 0, we are not giving any other force here, that is acceleration along x-axis is 0, that is horizontal acceleration is 0, right? So if the body is moving like this, if we kick a football, it travels a parabolic shape here, right? So whenever the object is traveling like this, it moves under the gravity of action alone now here, right? So let me take now here, it moves under the action of gravity, right? So let me take now here, ax is equal to 0, but what is acceleration along y-axis? Acceleration along y-axis minus g, that is acceleration due to gravity, is downwards. You know that acceleration due to gravity is downwards, right? If I leave it, it moves with the acceleration due to gravity. So what is the direction of acceleration due to gravity? Downwards. That is why I'll be taking acceleration along y-axis, that is vertical acceleration, is what we say here, minus g. Right, so do understand this. Always the horizontal acceleration is 0 and vertical acceleration is minus g. Right, okay. Next, let me take at this point. If I'm taking at this point, if I want to find what is its velocity, let me call the velocity is tangential. And what is the velocity? V. Shall I split it now, right? Okay, I'll be splitting this velocity along horizontal and along vertical here. Along x-axis and along y-axis. Come on, tell me, what will be the velocity along x-axis? The velocity along x-axis, do remember, as acceleration along x-axis is 0, the velocity will not change. Right? Because the acceleration along x-axis is 0, velocity will remain the same. The meaning of acceleration is 0 means we are not accelerating anything now, right? The speed remains same. So what is the speed now here? We have the speed is u cos theta along horizontal. It remains same. It will not change. Do remember, horizontal velocity will not change because the acceleration is 0. Right? So along y-axis, yes, it changes. How much? If I'm taking this as theta now here, let me call it as v sine theta. Right, so v sine theta. Do understand? Whenever an object is thrown upwards, first of all, its speed decreases, and at the maximum height, it is minimum. Speed is minimum. Again, speed increases. Okay, let me imagine like this now. See, do understand here? If it is traveling like this, if I am throwing the body with 3 meters per second here, right? If I am throwing it with 3 meters per second, what is the speed here? 3, right? What is speed here? 2. What is speed here if I am taking here, right? If the speed is 2 now here, right? Okay, if I am taking the speed is 1, and at this point the vertical speed, which I am speaking vertical component, because horizontal component is same here. I am speaking about vertical component. If it is 3, 2, 1, 0, and when it comes down on, again its speed increases 1, 2, and let me call it as 3 now, right? This is how the body moves in a projectile motion, right? See here, its speed goes on, decreases. At the point it will be minimum, and again it increases. So which speed I am speaking? I am speaking about the vertical component, u sine theta and v sine theta. By these two I can say that this is lesser than this now here, right? So come on, tell me what happens here at this maximum, that is the highest point, right? At the maximum height, what will be the velocity? The velocity will be in this direction. What will be this velocity? U cos theta. Okay, once again, what will be the velocity here? The velocity will be u cos theta. Along x-axis, it will be u cos theta, because it will not change. U cos theta, u cos theta, u cos theta. What is the velocity along y-axis? Velocity along y-axis is 0. Do you understand? At the maximum point, velocity along y-axis is 0. I already told you, it is 0 now, right? At the maximum height, it is 0. And when it comes down, again it increases. Okay, for example, if I am taking exactly at this position, right? What is the velocity? Velocity is in this direction. Come on, tell me, shall I split it along x-axis, y-axis? Yes. If I split along x-axis and if I am splitting it along y-axis, what is this velocity? This velocity will not change. What is that now here? U cos theta, u cos theta, u cos theta, u cos theta. This velocity will change. How much will be this velocity? V sin theta. If it is v, it is v sin theta. Right? Okay, do you understand? Velocity goes on, decreases, and at this point, again, when it comes down, it goes on, increases due to action of gravity. Right? So this is how the object moves in a parabolic shape. Right? Do you understand how actually velocity takes place? Right? Okay. Before we go with the further things, so some points that you need to remember is that the first point what we need to remember is horizontal component. What is the meaning of horizontal component? It is the component along x-axis. Horizontal component of velocity. Horizontal component of velocity is constant in projectile motion, right? In projectile motion, in parabolic motion, in projectile motion, horizontal component of velocity is constant. Okay, what is the horizontal component? Horizontal component is constant. This side component is constant. How much is that now here? U cos theta, right? Which component of velocity is constant during projectile motion? Horizontal component. What happens to the vertical component? Yes, let us go with the second one. That is vertical component. So do understand, vertical component of velocity varies with time. Varies with time due to gravity. Do understand? Vertical component varies with the time due to gravity. How does it vary? When a body moves upwards, the vertical component goes on, decreases, and at the maximum point it becomes 0, and again it goes on, increases when it reaches here, right? So that is vertical component of velocity varies with the time due to gravity. Vertical component varies, right? It decreases first and again it increases when it comes down here, right? But which component remains constant? Horizontal component. Okay, I will be speaking about this point now here. At what happens at the maximum height? Okay, see, let me write at maximum height. At maximum height. At maximum height, shall I say like this? At maximum height, what happens to the vertical component? Vertical component, let me call now here, at maximum height, vertical component. At maximum height, vertical component of velocity is how much? 0. Do understand this, right? At the maximum point, what is the vertical component of velocity, that is Vy, is 0. And what is horizontal component? And horizontal component, do remember, horizontal component is how much now here? That is u cos theta. Do remember, there is horizontal component. How much is horizontal component? U cos theta. Because this u cos theta will not change. Why will it not change? Because acceleration along horizontal is 0. If acceleration is 0, means its velocity remains the same, right? If a body moving with same speed, what is the acceleration? 0, right? We are not accelerating anything here, right? If acceleration is 0, means the body is moving with a uniform speed. That is the reason why we get all v cos theta along x-axis. This is sin theta. Yes, it goes on, changes here, right? So these things you need to remember about the projectile motion. How does the velocity change and how does the acceleration change along x-axis as well as y-axis. Now we will be learning about what are the parameters of the projectile motion here, right? We already studied there are 3 parameters. One is maximum height, the second one is horizontal range, and third one is time of flight. And we will be deriving equations for all these 3 now here. Now let us derive the expression for maximum height of a projectile. Okay, that is derivation of maximum height. Now let us derive the expression for maximum height of a projectile. Okay, now let us take how actually we derive, right? So since it is a motion in 2 dimensions, so let me take x-axis and let me take y-axis, right? We throw a body in this direction here, right? So with the initial velocity u, so we will be getting a projectile motion like this now here, parabolic, right? What is the initial velocity now here? U. And what is the angle of projection? That is theta, right? So in this motion, this kind of motion is called as projectile motion. So we are deriving what is the expression for maximum height. What is the maximum height here? Maximum height is nothing but maximum height reached by a projectile during its motion. Okay, this is height, right? What is the maximum height reached by the projectile? This is the maximum height. Okay, shall I say like this? This is the maximum height reached by the projectile, and I will be denoting it by h. Do remember, maximum height I will be denoting by h. So this is the maximum height reached by the projectile, and we are deriving what is the expression of that now here, right? So what is the initial velocity u, and this is theta, and we know that u is in this direction. We can split into 2 components as it is motion in a plane, 2-dimensional, right? Okay, I will be splitting this. U can be split like this, since it is theta, and this is which side? Which side? This is adjacent side. If it is adjacent side, so what do you get now here? U cos theta, right? If it is u cos theta, automatically the another vertical component, that is rectangle component, will be u sin theta, right? What is the horizontal component of velocity, u cos theta. What is vertical component of velocity? That is u sin theta. Now I need to find at this position, come on tell me, we have already studied this, at this position what is the vertical component, right? We know that horizontal component remains same throughout the projectile motion, right? But vertical component changes. Come on tell me, what is the vertical component at this position? Vertical component is 0, right? Whenever we throw this at this point, vertical component will be 0. Do you understand? Vertical component, shall I say like this, Vy will be 0. Where? At this position, right? At this maximum point, vertical component will be 0 here, right? Okay, now let us find what is the expression for this maximum height here, right? So to derive this, okay, this will be a 3 marks question that can be asked. Derive the expression for maximum height. So now I'll be using equation of motion, right? I'll be using the equation of motion. So which equation shall I use? V square is equal to u square plus 2as, because I have initial velocity, I have final velocity, and acceleration also we have. Okay, before that let me go with the acceleration. Come on tell me, what is the acceleration along x-axis? Acceleration along x-axis is 0 during the projectile motion. These things you should understand, right? What is the acceleration along y-axis? That will be minus g. What is y minus g? Because it is downwards, right? So this is common for all the projectile motion. Acceleration along x-axis 0, acceleration along y-axis minus g. Okay, now using equation of motion, what is that equation? V square is equal to u square plus 2as. We know that whenever I speak about a two-dimensional motion in a plane, this can be written along x-axis and along y-axis. Come on tell me, which axis shall I use, right? Since the body is moving upwards, I will be using which axis now here? Y-axis. First thing what you should understand here is which axis we need to use now here. Since we are discussing about maximum height is along y-axis. So that is why, shall I say, along y-axis. We know that this equation can be written along both the axes, along x-axis and along y-axis. Which axis we need to take, that you need to understand here, right? So this equation we can write like this. How we can write? Vx square, that is equal to ux square plus 2ax into x. Acceleration is like this. Vy square is equal to uy square plus 2ay into y, right? There are two equations. In these two equations, which equation I need to take? I need to take along y-axis. Why only y-axis? Because this maximum height which I am speaking is along y-axis. So I will not be using this. This I will not be using. I will be using only y-axis equation. That is why I write along y-axis. That too where now here? Along y-axis at maximum height. At maximum height. I am speaking about this maximum height. Okay, write the component of this equation along y-axis. Okay, come on tell me, what is component of v along y-axis? Vy square. What is component of u? Uy square plus 2. What is component of a? Ay. What is displacement? What is displacement along y-axis? Displacement along y-axis is y down here, right? So displacement, I already displacement along x-axis, I have replaced it by x. Displacement along y-axis, I replaced it by y. So instead of yes, I will be writing displacement along y-axis. Shall I take it as that? What now here? Y. Now I will be replacing with the terms what you know. Come on, tell me, what is velocity along y-axis? Where at maximum height? Come on, tell me. The body is moving from this point to this point. I am taking only this half position here. This is I am speaking about this. If the body is moving from here to here, what is the initial velocity? This is the initial velocity. What is final velocity? This is the final velocity, right? Okay. Vy square. What is Vy at this position? Vy is 0. So shall I take it as 0? Yes, 0. What is Uy? Come on, tell me. What is u along y-axis? What is Uy now here? U sin theta. Shall I say like this? U sin theta whole square plus 2. What is Ay, man? Ay is how much now here? Minus g. So I will be taking it as minus g. Okay. What is y? This is this. What is this y? This y is nothing but what now here? Height. The distance y. This is y now here along y-axis. What is y along y-axis? H. So shall I replace y by what we say now here? H. Now I need, what is the expression for h? I got expression for h there. Okay, shall I continue? 0 is equal to u square. Shall I say like this? U square sine theta square, that is sine square theta. Do you understand? Sine theta whole square is nothing but sine square theta. Both are nothing but same, right? Okay. So that is u square sine square theta plus into minus 2g, what we say here, h. We want expression for h, so I will be bringing this to this side. So what do I get? 2gh, okay, that is equal to u square sine square theta, right? What is the expression for h now here? H is equal to u square sine square theta divided by, what shall I say now here, 2g, and this is the expression for maximum height. Do you understand? What is the expression for maximum height? U square sine square theta upon 2g. Do remember, this is important, right? So you need to remember what is the expression for maximum height. So this is, by this formula we can solve some problems now here, right? So do remember, maximum height h equal to u square sine square theta upon 2g. What is u? That is initial velocity. What is theta? That is angle of projection. What is g? Acceleration due to gravity. We know what is acceleration due to gravity? 9.8 meter per second square, right? Okay. So h equal to u square sine square theta upon 2g, right? So this is the formula for maximum height, and this is how we need to derive it, right? So we need, in the question paper, the question will be asked like this: derive the expression for maximum height for 3 marks. So we need to draw this neatly, we need to write it, and we need to get this expression, that is u square sine square theta upon 2g. Now, as usual, I said, when will be the maximum height of any projectile now here, right? If you want to throw an object for a maximum height, which angle we need to project it? So there is one angle, which is that angle here, sine theta. I already told you, maximum and minimum depends upon the trigonometric function which is present in that equation. What is trigonometric function now here? Sine theta. Come on, tell me, what is sine theta? If I am speaking now here, sine theta, see, whenever I speak about sine theta, when is sine theta maximum? Sine theta is maximum if theta is equal to 90 degree. We know if theta is equal to 90 degree, it is maximum, because sine 90 is what we say here, 1, right? So since theta will be maximum at angle 90 degree, if theta is equal to 90 degree, the body will reach the maximum height. We can write like this: body will attain maximum height if angle of projection is 90 degree. Do you understand? This will be one more question, right? So when will the body attain the maximum height? If angle of projection is 90 degree, it will attain the maximum height. For example, if I want to throw this chalks now here, right? For example, if I want to throw this, right? If I throw like this, it will attain this height, right? If I throw a little bit angle, it will attain right here. Maximum height, when it will attain? When I throw the object at 90 degrees with the horizontal. If I throw maximum, so it will reach at the maximum height. When will the body reach maximum height? If the angle of projection is 90 degree, the body will reach at the maximum height. You want to throw at a maximum height, what should be the angle? Angle should be 90 degree, right? So do you understand? For maximum height, what should be the angle of projection? Angle of projection must be 90 degree. Now let us derive the second parameter of projectile motion, that is time of flight. We already studied that the time of flight is nothing but time taken by the projectile to reach the ground after it was projected. So what is the time taken for the flight? That time is called as time of flight, and we denote time of flight as capital T. And let us derive what is the expression for time of flight here, right? Okay, now let us do the same thing. Let us take a projectile motion. As you know that projectile motion is a two-dimensional motion, so we require two axes, x-axis and y-axis, and I am projecting it along this direction. So the object moves like this and it reaches here. Let me take like this, right? So this is along x-axis, right? And this is the projectile, and you know what is this initial velocity? U. What is the angle of projection? Theta. What is velocity along horizontal? U cos theta. This is adjacent side. What is along vertical here? U sin theta. Right? And you also know that what is the acceleration along x-axis? Acceleration along x-axis is 0, right? Because the object moves under the action of gravity alone. So what is acceleration along y-axis? That is minus g. What is acceleration of y component at this point? Acceleration of y component at this point is what we say, sorry, not acceleration, velocity, sorry. Velocity along y-axis, what is the velocity along y-axis is what we say here, 0 at this point here, right? Okay. Now, what we need to understand here is, we are finding what is the time of flight. Okay, one thing what we need to understand here is, if the object is thrown like this, it follows like this, right? And one interesting fact what you need to understand here is, when the object is thrown in air, the time taken by the object to go at the maximum height will be equal to the time taken by the object to come to the ground. For example, if I throw this duster like this, if the duster takes 2 seconds to go up, it will take 2 seconds to come down. Okay, do understand this, right? If it takes 2 seconds to go up, it takes 2 seconds to come down, right? So shall I say like this? The time taken by the object to go at the maximum height will be equal to time taken by the same object to come to the ground, right? So the time taken by the object to go to the maximum height, that is called as time of ascent. Okay, let me use this word. So this is called as, that is ascent. It is called as ascent, right? Ascent means the body which goes at the maximum point. This kind of traveling is called as ascent here, right? So it is time of ascent, right? So the body which comes down, that is called, let me call it as, it is descent here, right? This is ascent, and what we say, this is what, that is descent, right? Time of ascent equal to time of descent. Do you understand, right? Time taken by the body to go up will be equal to the time taken by the body to come down, right? So that is time taken body to go up, that is called as time of ascent. To come down, the time taken by the body, that is called as time of descent here, right? Okay, one thing what you need to understand here is that I will be writing here, time of ascent is equal to what we say here, time of descent. Time of ascent is equal to time of descent, right? Shall I say, what is the time taken by the body to go up? Let me take it as small letter t, right? So if it takes t to come down, again it takes t. Therefore, shall I say like this, what is time of flight, right? What is time of flight? We write it as capital T. What is time of flight? This is a t plus t. How much that we get now here? It is 2t. Do remember this, right? Time of ascent equal to time of descent, that is equal to t. What is a time of flight? That is t. That is t plus t, that is 2t, right? It is the time taken by the projectile to reach ground after it was projected, means the time taken by the full journey, that is 2t. That is nothing but what we say here, time of flight. Now, what we will be doing, again we will be using equation of motion to derive what is the expression for what we say here, t here, right? Okay, now shall I say like this, what is time taken to reach maximum height? Maximum height, come on, tell me. Maximum height. What is time taken to reach maximum height? This is the maximum height. What is the time taken? If the total time taken is capital T to reach up, what is the time taken? That is t divided by 2, right? Half of the time of flight, right? Time taken to reach maximum height. What is the time taken to reach maximum height? T by 2, half of the time of flight now here. Now, which equation shall I use? I want t. T means, shall I use equation of motion like this? Okay, see, using equation of motion, shall I say like this? Using equation of motion which has t in it. So what is that now here? V is equal to u plus at. Shall I use like this, right? Okay. Why did I use this? Because it has t now here, right? V is equal to u plus at, right? And again, since it is motion in a plane, it has two equations. One is x-axis and along y-axis. Vx equal to ux plus axt. Another one is vy is equal to uy plus ayt. The next question arises here is, which component I need to use? Since the object is moving upwards, which component shall I use now here? Y component. So shall I say like this, along which axis? Y-axis. Since I am using y-axis, I don't want this x-axis. I will be removing it. I will be using this equation, right? Along y-axis, that too where now here? at maximum height. First I need to find at maximum height. I will be taking like this one here. Along y-axis at maximum height. Okay, write this equation along y-axis. Okay, shall I write this? V. Shall I take Vy that is equal to U? Shall I take Uy plus A? Shall I take Ay? The time. What is the time taken to reach upwards? Shall I take T upwards? I will be substituting now, right? Okay, since time is a scalar quantity, I cannot write Ty, right? Time is a scalar quantity. Only when it is a vector quantity, I can split into x and y axis now, right? Okay, now I will be substituting. What is Vy at the maximum height? I am speaking about along x-axis, that too where now here? Maximum height. What is the maximum height? Velocity along maximum height, that is how much now here? 0. Shall I write it 0? Right? That is equal to Uy, that is initial Uy along y-axis. What is that now here? U sine theta. U sine theta, right? Okay, plus what is Ay, man? We know what is Ay. This is same for all the projectile motion. What is Ay? That is minus g. That is minus g. What is the time taken to reach the maximum height? We know what is the time taken to reach the maximum height? T by 2. So here, shall I write T divided by 2? I want equation for T, so I will be taking this to this side. Since it is minus, when it comes this side, it will become plus. That is Gt divided by 2, that is equal to U sine theta. Okay, if it comes this side, it will become minus Gt by 2. If it comes this side, it will become Gt divided by 2. Okay, I want T. What is the T equal to? Shall I bring to that side? 2U sine theta divided by what we say here? G, and this is the expression for time of flight. Do you remember? What is the expression for time of flight? There is T is equal to 2U sine theta divided by G. Right, do you understand? What is the expression for time of flight? 2U sine theta divided by G, and you need to remember these expressions, right? We already derived the expression for maximum height, U square sine square theta upon 2G. Time of flight, the expression is 2U sine theta upon G. So this is derivation of time of flight. Right? Again, it will be a 3 marks question. Derive the expression for time of flight, and we need to draw this, and we will be arriving at this equation. T is equal to 2U sine theta upon G. Now let us derive the expression for horizontal range of the projectile. This is the third parameter, right? Horizontal range of the projectile. So what is horizontal range? It is the distance covered, horizontal distance covered by the projectile during its motion. For example, it moves like this. How much distance it covered horizontally? That is called as horizontal range. Range is nothing but distance, right? Horizontal distance covered by the projectile during its motion is called as horizontal range, and this horizontal range is denoted by capital letter R, and we are deriving what is the expression for horizontal range of the projectile. Okay, to begin with this derivation, let me take again 2 axes, because projectile motion is a motion in a plane which has 2 axes, x-axis and y-axis. We are throwing a projectile along this axis so that in this way, so that it follows the parabolic nature here, right? What is this velocity? This velocity is u. And what is this angle? Angle of projection. Let me take it as theta now here, right? Again, I will be resolving this along x-axis. This is adjacent side. So what do you get now here? U cos theta. What do I get here? That is u sin theta, right? We are deriving the expression for horizontal range. What is horizontal range? Horizontal distance covered, right? So what is horizontal range? This is the horizontal range, right? So horizontal distance covered, right? From this point to this point, what is the horizontal distance covered by the projectile, right? How much far the object will fall after throwing. So that distance is called as horizontal range, and let me take that horizontal range as R here, right? Okay, now we know that. Shall I take like this? What is the horizontal range? We are deriving the expression for a horizontal range, and let me tell you, this horizontal range, is it along x-axis or y-axis? Because before we start with the derivation, first we need to understand, is it x-axis or along y-axis, right? Horizontal range, it is along x-axis, so that I can use only the x-axis formulae, right? Okay, first of all, let me write like this: along which axis? X-axis. Why x-axis? Horizontal range is along x-axis now here, right? So let me take horizontal range, or simply I can write it as range. What is the formula? What is horizontal range? It is horizontal distance covered. horizontal, what we say here, distance covered. Right, horizontal distance covered by the projectile. This horizontal distance is called as range. Right, this is initial point and this is the final point, and the minimum distance between initial point and the final point. So this distance is also called displacement. Right, shall I take like this? This can also be called as what we say here, displacement. That is horizontal distance covered. This horizontal distance covered, that can also be called as what we say here, displacement. And we know what is the formula for velocity. Come on, tell me, what is the formula for velocity? Velocity is distance traveled or displacement divided by what we say here, time taken. Now I need, what is the expression for displacement? What will happen? Displacement equal to velocity into time. Shall I take like this? This is velocity into, what shall I take now here? Time. Right? Okay. This is nothing but displacement. What is the formula for displacement? We have velocity into time, because velocity equal to displacement by time, displacement equal to velocity into time. Come on, tell me, what is velocity along x-axis? What is the velocity along x-axis? That is u cos theta, right? Into, what is the time taken to reach the object to the ground after it was projected? Shall I take capital T? What is capital T? It is called as time of flight, right? So the time taken to reach the ground after it was projected, the time taken is nothing but time of flight. So instead of this secondary time of flight, velocity I will be writing u cos theta because it is along y-axis, and we know that is equal to u cos theta. And you know the formula for t. What is the formula for t? Just now we have derived. What is the expression for time of flight? That is 2u sin theta upon what we say here, g. 2u sin theta upon g. That is the expression for time of flight that we have already derived it. Do remember, the time of flight, the formula is 2u sin theta upon g. That equation I have used here. Right? Okay, shall I take like this? That is equal to, if I am calculating, that is equal to u into u. What shall I take now here? It is nothing but u square. What do I get? Other thing, 2 sin theta cos theta. 2 sin theta cos theta divided by what we say here, g. Right? See here, u into u square, 2 sin theta cos theta. But we have the formula for 2 sin theta cos theta. Do you understand here? We have the formula. What is the formula? Sin 2 theta is equal to 2 sin theta cos theta. Right? We have the formula. What is the formula? Sin 2 theta equal to 2 sin theta cos theta. This is the trigonometric identity. Right? So whenever you have 2 sin theta cos theta, it can be replaced at sin 2 theta. Okay, what do I get here? Okay, shall I write here? Right? The next step I will be writing here. Okay, let me take now here, that is equal to, that is range. Shall I take r equal to u square? Shall I take like this? Instead of writing 2 sin theta cos theta, I will be writing sin 2 theta. Do remember, sin 2 theta equal to 2 sin theta cos theta divided by, what do I get now here? G, and this is the expression for horizontal range. Right, again it will be a 3 marks question. Derive the expression for horizontal range. So we need to write this, and we have derived what is the expression for horizontal range of the projectile, that is r is equal to u square sin 2 theta upon g. Do you understand this? Right? Okay, u square sin 2 theta upon g, that is the expression. Right? Okay, now after completing this expression, let me move on to when will the horizontal range will be maximum. The next question arises here is, when will be the horizontal range maximum? Let me take that now here. Right? Okay, in this case I will be taking like this. Right? We know what is the expression for horizontal range. Horizontal range is maximum. I need to find what is the horizon, when is the horizontal range maximum. Horizontal range of projectile is maximum. When is it maximum? Do you understand? Horizontal range means this is the range. Horizontal range, when it will be maximum. Okay, first thing, we have already understood that when is the body attains a maximum height? At angle of projection is 90 degrees. This we have learned. Now we are finding what is the horizontal range of maximum. When is the horizontal range of maximum? When is it maximum? Right? So horizontal range is maximum if angle of projection, if angle of projection is, do remember, at 45 degrees. right? If angle of projection is 45 degrees, right? If you want to throw at a larger distance, we not need to throw it at 90 degrees. We need to throw in a such a way that the angle of projection is 45 degrees. If it is 45 degrees, it will reach at the maximum distance, right? Do you understand? When will the body reach at the maximum range? When the angle of projection is 45 degree, right? So you will come to know, if you have played a Angry Birds game, right? In that Angry Birds game, you need to know the angle of projection and you need to hit it. If you want to hit it too far, you will be stretching it in a such a way that angle is 45 degrees, right? In football also, if you want to kick through a larger distance, you need to kick it along 45 degrees, right? So at 45 degrees, horizontal range is maximum. Do you understand this? This is a one mark question, right? When will be the horizontal range of projectile is maximum? If angle of projection is 45 degrees. Okay, we know. Shall I write like this? R is equal to u square sine 2 theta upon g. Okay, what will be the maximum range? Shall I calculate? Okay, shall I write like this? U square sine 2. What is theta to be maximum? That is 45 degrees, right? So divided by g, that is u square sine 2 into 45 is 90 degrees. That is the reason I told you, no? So when it will be maximum? When this trigonometric function will be maximum. When the sine 2 theta will be maximum? Sine 2 theta will be maximum when angle is 45 degrees, right? When sine theta is maximum? When theta is 90 degrees. When sine 2 theta is maximum? When angle is 45 degrees. That is why I have written angle of projection is 45, right? Divided by g. What is sine 90? Sine 90 is 1. What is remaining? U square divided by g. So that is maximum range. What is the maximum range? Maximum range will be u square divided by g, and maximum range will be at angle. What is that angle now here? 45 degrees. Do remember this, right? So this is the maximum. Okay, before I end this session, let me tell you how actually the projectile motion will take place, right? For example, if I want to throw, let me tell you like this. This is the projection here. Let me take this as x-axis and this is, let me take it as y-axis. Come on, tell me. If I want to throw for a maximum distance, which angle I need to maintain? The angle of projection must be 45 degrees. Okay. This is 90 degree. We know this is 90 degree. And exactly at the half, this is 45 degree, right? This angle is 45 degree. If you throw a projectile exactly at 45 degree, it will reach at the maximum distance, right? It will cover maximum distance. Do you understand this? It will cover maximum distance. Right, what is this distance? U square by g. We have already understood this, right? So what is this angle? This angle is theta is equal to how much now here? 45 degrees, right? For example, if I make it 30 degree, what happens now here, right? If I decrease the angle, it will fall here, right? So what is the angle now here? This angle is, what is that now here? 30 degrees, right? If I again decrease the angle, what happens now here? It will fall here. So what is this angle now here? This angle is, let me take it as 20 degree. Do you understand? Right. So angle is 20 degree, it will fall here. Angle is 30 degree, it will fall here. Angle is 45 degree, it will fall at the maximum. Right. Another one interesting thing here is, if you throw it at 60 degrees, what will happen? So just to understand, if I am throwing this at 60 degrees, if I throw it at 60 degrees, it will fall here. That is the interesting point here, right? So what is the angle now here? Angle is how much now here? 60 degree. If it is 60 degree, it will fall at this point, right? So angle is 60 degree, it will fall at this point, right? Do remember two angle of projections. Let me write one point here. Before I end this session, let me give you a note point. Two angle of projections will have same horizontal range. See here. Two angle of projections will have same horizontal range. Condition is u is constant, right? I am not changing u. Initial velocity I am not changing. In this whole case I am not changing initial velocity, right? Okay. Two angle of projections will have same horizontal range if sum of angle of projections is what we say here, 90 degree. Means theta 1 plus theta 2. If it is 90 degrees, theta 1 plus theta 2, if it is 90 degrees, it will be having same horizontal range. That is why the reason I got the same range even for 30 degree and even for 60 degree, because 60 plus 30 is equal to 90. Did you understand? Right? So this is the main important thing what you understand. If the sum of angle of projection is 90 degree, it will be having the same horizontal range. Now come on, tell me at what angle. See here once again, at what angle will it have the same horizontal? If it is 20, so I want 90, so which angle I need to say? 70, right? If I send it at 70 degrees, if I send it at 70 degrees, it will fall at this point. So what should be this angle? This angle must be 70 degree, because 70 plus 20 will be 90 now, right? 60 plus 30 will be 90. Okay, at 45 degrees it will be maximum, that is R max, that is U square divided by G. Do you understand, right? So whenever you need to throw at a larger distance, you need to throw in a such a way that angle of projection is 45 degrees, right? So these were all the expressions for parameter of a projectile motion. One is maximum height, the second one is time of flight, and the third one is the horizontal range. Thank you.